All right, guys, I wanted to go through these last three examples from the compound interest problems just to help us with this. So we have question number 7 from the notes. Danae plans to save $13,000 that she made off of selling her car. She puts the money into the bank account that has a 7.2% interest rate that is compounded quarterly. How much money will Danae have if she leaves her money in the bank for 10 years? So they're saying she's going to take this $13,000, put it in the bank, and leave it there. So let's identify the important numbers that we have here. She plans to save the money that she already has. So the $13,000 is her principal amount. So we'll plug that in for P. She puts the money into a bank account that is 7.2% interest. When we divide that by 100, I get an R value of 0.072. It is compounded quarterly. Quarterly is 4 times a year, so your N value is going to be 4. How much money will Danae have if she leaves in her bank? So that's going to be your T when we do the actual prediction. I do want to write the model out first. So we'll do the 10-year prediction out here once we have a model to work with. So to get the final amount, A, we're going to take our principal of $13,000. She's earning interest, so it is a plus problem. 1 plus R divided by N. N is your compound. Close it, and then it's N times T. So it's 4 times, right now we're just saying any time value this would work for. So the model, we don't know the time. It's for any time we would ask about. Over here, we're asking specifically about 10 years. So that means we're going to take the 10 and we're going to plug it in. 1 plus 0.072 over 4, and 4 times 10. So you want to be careful when you're putting this in your calculator. So I have my calculator here. Let's see, we've got 13,000, parenthesis 1 plus 0.072 divided by 4, close the parenthesis. To get into my exponent, I'm going to do my up arrow. Mine shifts me up. If yours doesn't, you probably want to just give the total. So 4 times 10 is 40, so I'm just going to put 40 in there. I'm not going to worry about doing the 4 times 10. I press enter and I get $26,537.16. So after 10 years, she's doubled her money, $26,537.16, with an interest of 7.2%. But that was 10 years of sitting there doing nothing with it. So that's a long time to wait to get it to double and not ever touch it again. Let's go ahead and try the next one from the notes. Question number 8. 8 is a little bit different. Let's read it. So Julie wants to have $5,000 in 2 years. It's not that she has $5,000 now, she wants it in 2 years. So that $5,000 is actually my A amount. In 2 years, so 2 is going to be my T value, because she wants to buy a used car. She finds an account that will pay 5% interest, so 5% divided by 100 gives me an R value of 0.05. It's compounded monthly, so monthly is N equals 12. How much should Julie put into this account so she will have $5,000 at the end? So what we're looking for is we don't know what P is. So that's what we're going to have to solve for. What I'm going to do is we're just going to go ahead and plug this in and we're going to solve as we go. So we're not going to do a model for this. We know the answer. The answer is $5,000 because that's what we want. That equals, so A equals P, well that's the one thing we don't know. So it's going to stay a variable. And then we have 1 plus R divided by N equals N times T. And T is 2 years. Okay? So before, we would just multiply these two together to find out what the final answer is. But what I need to get P alone. So to make this a little bit easier, I'm going to find out what this number is. So taking my handy dandy calculator, I'm going to put it in just like I see it. I've got 1 plus 0.05 divided by 12, close it, and then I'm going to raise up 12 times 2 is 24. And here's my number, 1.1. Let's give it several decimal places. I don't want to round too much right now. So 1.1049413. And that's going to equal 5,000. To get the P alone, because this is what we're trying to find, this says P times this number. So to undo that and get P alone, I'm going to divide by that number. Same over here, 1.1049413. So it will cancel there. So my principal will be whatever 5,000 divided by 1.1049413 is 4525 point, and that's that'd be 12 cents, except the next one is a 7, so we'll go ahead and round it up to 13 cents. So to have that much money in 2 years, Julie's going to have to put $4,525.13 into her bank account today. So just be real careful when you're reading these on how it's asking and what it's giving. So let's try the very last one. From the notes, number 9, you need to save $6,000 in 3 years. So we're saying in the future we need this much money for a down payment on a house. How much money should you invest into savings? Should we invest? That means we're looking for P here. Into a savings account that earns an interest of 2.5% compounded quarterly. Okay, so we have compounded quarterly, so that gives me an N of 4. There's my rate. If I divide it by 100, I get an R of 0.025. What else do I have? Oh, this is what my final amount needs to be. So I have the money for my down payment. In 3 years, that's my time value. So let's plug in what we know. We're not going to do a model because we're looking for a different value than the final end value. So in the end, I need to have $6,000. That's the principal. That's what we're looking for. We have 1 plus R, which is 0.025, divided by N. Close your parentheses, and then it's N times T, and T is 3. So this problem is going to work exactly like the previous problem did. I need to find out what this number is next to the P, so I can divide it off and get P alone. So if I have 6,000 equals P times, well, I don't know. Let's give it a try and see what we get. We get parentheses 1 plus 0.025 divided by 4 raised to 12, because 4 times 3 is 12. Okay, and that gives me 1.077632. I'm just trying to get several decimal places out there and not stop too early. So to get P alone, this is P times that number. So I'm going to divide by the number on both sides. Here it cancels out and it's going to leave P all by itself. And 6,000 divided by 1.077632 is 567.76. So in order to have $6,000 in 3 years, based on that interest rate, she has to deposit $5,567.76. So pretty much all of it she has to deposit now. So it's not maybe the best savings plan for her. So hopefully this helps you with your homework. Remember, your homework is going to be 1 through 6 on the back of this page that we're writing on right now. See you tomorrow.